Okay, so I apologize. The last video cut off before we could finish this problem. If you remember, we're trying to find the zeros of this polynomial. We found that x equals 4 from our calculator, and then we're going to use synthetic division to divide that solution out to see what type of quadratic we were working with. So with synthetic division, I get x squared plus 4. Setting that equal to 0, it's very easy to solve. X squared is negative 4. Take the square root. X is plus or minus 2i. So our solutions to this polynomial are x can be 4 and then plus or minus 2i. The plus or minus 2i is why the calculator only shows the one solution of 4. Lastly, what you need to know from the algebraic units are your exponentials and your logarithms. So we talked a lot about exponential equations. There are y equals a1 plus or minus r to the t. And remember, this represents growth or decay. This formula you've seen since Math 1, so it's least likely to be used, but it can be used. Remember, a is your initial amount. R is your rate as a percent, so we need to change it to a decimal. And then t, of course, is time. Plus means growth, minus means decay. Then there's the new formula, y equals PERT. And this is when we compound things continuously. This will come up on your exam, so you need to know everything about it. Compounded continuously. That's not how you spell that. The P is your initial, your R is your percent, and your T is your time. The reason why this is important is because of this little e right here. That e works with our natural logs. And if you remember in our calculator, the e is second division, or second ln will give you e to an exponent. So these type of problems will say compounded continuously in them for you to solve. And they're typically word problems. If you have an equation like y equals 1000 e to the 0.07t, and you're asked, when will the amount in the account be, I don't know, $1,500? So we would plug in $1,500. And then we need to solve this for t. One way to do that is to solve it by hand, which would be dividing. So 1,500 over 1,000 is 3/2 or 1.5 equals e to the 0.07t. Remember, the way we solve exponential equations is to work them and write them into logarithm form. So that would mean the natural log of 3/2 equals 0.07t, because the natural log and e undo each other. Then I would simply divide by 0.07. Type this in my calculator. Natural log over 2 divided by 0.07. And 5.79 is how long it would take. Anytime you see e, this is how you undo the equation. E and natural log are special case logs, whereas our traditional log is y equals log bx. B is our base, x is just an x, y is just a y. Remember, this implies that b to the y equals x. You need to be comfortable going back and forth between both forms. For example, 8 equals log 2 of 256 means that 2 to the 8th is 256. You need to be comfortable sketching graphs or looking at the graphs. Remember, an exponential looks like this. And because logs and exponentials are inverses of each other, then that means a log graph is going to go through 1, 0 or look like this. So this is our log graph. You can always type it in your calculator. For example, if you're asked to graph y equals 3 log 2 of x. Remember, this is math. Option A will bring up the log base function and will allow you to type in that base of 2. If you're not given that, then you need to put this in exponential form and do it by hand. The last thing is the logarithmic rules. So remember, if you have like the log of 7, a base 7 of 2 plus log base 7 of 10, that's the same as log base 7 of 20. When we add logs with like bases, we can multiply their constants, and vice versa. We could break this up into this. The same is similar for subtraction. In this case, we would have division, which would be log base 7 of 1 over 5. And you could take that a little bit farther. The last is if there's a coefficient, that becomes an exponent. So log base 7 of 2 to the third, or log base 7 of 8. Remember, when we have like bases, those bases cancel. So something like this would just equal 2. Again, with these, you can type them in the calculator with the log base option and double check your answers. This ends the algebraic review. Please work on the review sheet. If you have any questions, ask Ms. Lewis.